In this video we will look at the time library and the date time library, how to use the sleep function, how to add and take away dates, and how to make an analog and a digital clock using these libraries. First, let's open a new blank Python script and name it time example. The time library comes pre-installed with Python, but you need to import it to make use of it. To import the library, at the top of the script, type import time. Now, the time library has a useful function called sleep, which is used to pause the script or program for a set amount of time. To demonstrate this, let's write a few lines of code. After the import time statement, on the next line down, let's write a print statement by typing print, open bracket, apostrophe, first statement, apostrophe, close bracket. Then on the next line down, let's write our sleep function. Type time dot sleep, open bracket, 5, close bracket. This will pause the script for 5 seconds. On the next line down, write another print statement, type print, open bracket, apostrophe, second statement, apostrophe, close bracket. Then run the code and see what happens. In the shell window, the first statement should display straight away, then after 5 seconds the second statement will be printed. Here we can see how the sleep function paused the script from running for the 5 seconds given. Now let's do a similar thing, but in a for loop. Comment out the 3 lines of code we have just written. Then on the next line down, type for I in range, open bracket, 5, close bracket, colon. Then enter down to the next line, then type time dot sleep, open bracket, 1, close bracket. Then on the next line down, type print, open bracket, I, close bracket. Then run the code. We can now see, in the shell window, that 1 is added each time the 4 statement loops, and the script pauses for 1 second between each loop. Now let's see how to get the current time. In Python there is another useful library for this called date time. At the top of the script, under the previous import statement, type from date time, import date time. Then on the next line down, type current underscore time equals date time dot now, open bracket, close bracket. This creates a variable, which we have named current underscore time, and uses the date time library to pull back the current date and time. Let's write a print statement to display this to the shell window by typing print, open bracket, current underscore time, close bracket. Now run the code. Here we can see that the current date and time are brought back. If we only wanted the date brought back, or if we only wanted the time brought back, we could do this by specifying the format that we need by using a function called strf time. At the end of the current time variable, type the following .strf time, open bracket, apostrophe. Then type percentage symbol, capital letter, Y, hyphen, percentage symbol, M, hyphen, percentage symbol, D, space. So far this brings back the year, month and day. Then type percentage symbol, capital letter H, colon, percentage symbol, capital letter M, colon, percentage symbol, capital letter S. This brings back the hour, minute and second, then finish off by typing apostrophe, close bracket. Now if we run the code, we can see that the date and time is brought back without the milliseconds. The time library also has a way to display the current date and time, like the datetime function has. However, its format is slightly different. Under the print statement, type another print statement as follows: print, open bracket, time, dot, see, time, open bracket, close bracket, close bracket. Then run the code. Here we can see that the current date and time is brought back as well, so we now have 2 methods to get the current date and time. Now, in our for loop, remove the print statement that prints I instead of it, copy and paste the current underscore time variable, as well as the print statement that prints it. If we now run the code, we can see that the time updates every second. So how would we add or take away to the time? For instance, what if we want to add 48 hours, 40 minutes and 20 seconds to the current time. Well, to do this, we could use the time delta function. In our import date time function, at the end of it, type, comma, time, delta. This imports the method from the date time library. Now in our for loop, on the next line down, let's create a new variable to display the current time, plus the value specified, by typing added underscore time equals date time dot now, open bracket, close bracket, plus symbol, time, delta, open bracket, hours equals 48, comma, minutes equals 40, comma, seconds equals 20. Close bracket. Then on the next line down, if we write a print statement to print this value to the shell window, by typing print, open bracket, added, underscore, time, close bracket. Then if we run the code, we can see that we have two values printed each second, one for the current date and time, and one for the date and time, plus our specified value. Notice how the milliseconds are shown on the date, which we have added to. This is because we haven't used the strf time function on it yet. So that is how we can add time to the current time. To take away time, we would just replace the plus symbol for a minus symbol. If we do this, then run the code again, we will see that the time specified is taken away from the current time. Let's use the knowledge we have so far to make a digital clock and an analog clock in Tkinter. As we only need the time portion, in the for loop, remove the year, month and day portion of the current underscore time variable. We won't be adding or taking away from the clock, so comment out the added, underscore, time variable and its print statement. If we run the code again now, we can see only the time portion of the date time method is brought back. Now let's create a basic Tkinter window. At the top of the script, enter a new line and type, import, Tkinter, as tk. Then after the import statements, let's create a window, type, window, equals tk, dot, tk, open bracket, close bracket. On the next line down, type, window, dot, title, open bracket, apostrophe, clocks, apostrophe, close bracket. On the next line down, type, window, dot, geometry, open bracket, apostrophe, 1000 x 500, apostrophe, close bracket. This will create a new window, make the title of the window, clocks, and set the size of the window to 1000 pixels wide by 500 pixels height. To contain all the Tkinter code inside of a main loop, at the bottom of the script, type, window, dot, main loop, open bracket, close bracket. Then, let's run the code. Notice how, in the shell window, the for loop is running and only when the for loop ends, does the window get created. This is because the Tkinter window only launches when the main loop statement is written. In our code, the main loop is at the end of the script, so the window won't be visible until the end. In order to have the window display first, for now, we can place the for loop inside of a function. Above the for loop, type, def, update, underscore, time, open bracket, close bracket, colon. Then highlight all the for loop code and press tab to indent it. This will stop the code from running until the function is called, which temporarily solves the issue. Now run the code. Here we can see that the window loads as normal. Let's make a label, which can be used for our analog display. Above our newly created function, type, label 1 equals tk, dot, label, open bracket, window, comma, text equals, apostrophe, 0, 0. Colon, 0, 0, colon, 0, 0, apostrophe, comma. This just represents a blank time when the window launches. Then type, font, equals, open bracket, apostrophe, Arial, apostrophe, comma, 70. Close bracket, close bracket. Enter to the next line down. We need to place this onto the window, so let's type, label 1 dot place, open bracket, x equals 100, y equals 100, close bracket. Then run the code. Now we should have a label printed to our screen. With our current method in our update, underscore, time function, if we called this in the code, the same thing would happen as before we added the for loop to a function. The loop would run before the main Tkinter window was called. But what we can do is call the window to update as part of the function. Firstly, in the for loop, add a new line, and let's display the current time to the value of our label. Type label1 dot config open bracket text equals current underscore time close bracket. Now on the next line down, type window dot update open bracket close bracket. This will force the window to update each time the loops run. Now if we call the function by going to the end of the script, just above the main loop and typing update underscore time open bracket close bracket. Then run the code, we can see that the window is updated for each time the loop runs. We no longer need the code printed to the shell window, so we can comment out the print statement. At the moment, the clock only runs for 5 seconds. If we want the code to run continuously, we need to change the statement from a for statement to a while statement in place of the for statement. Type while true, colon. Now if we run the code again, we can see that the clock keeps updating past 5 seconds. The problem with this method is that the time.sleep method pauses the entire program for the duration of the pause as the main loop hasn't been called yet, meaning that if we had other widgets in our window, such as buttons or text entry fields, they would only operate every second, so the screen essentially freezes until the next window update is called. To get round this, Tkinter has another method we can use called after. Let's use this. Firstly, comment out the update underscore time function call, as we won't be using this. Then above the main loop, let's create another function, type def update underscore time 2 open bracket close bracket colon. Then press enter to enter down. Now, from the first update time function, copy out the line of code for the current time variable and the line of code for the label config statement and paste them in our newly created function. Then enter a line down. Now type label 1 dot after open bracket 1000 comma update underscore time 2 close bracket. What this does is, after 1000 milliseconds, which is equal to 1 second, the function update underscore time 2 will be called, which then updates the text value of the label 1. This essentially creates a loop, as the function call is within the function itself. We just need to initialize this function now, so at the bottom of the script, above the main loop, enter a new line and type update underscore time 2 open bracket close bracket. This will call the function, which will then call itself every 1 second. If we now run the code, we can see that the value of time updates every second. If we had more interactable widgets on the screen, we would also be able to press them as the script is not paused like it is in the time sleep function, so this is a much better method to use with Tkinter. Let's edit the window a little to make it look more like a digital clock. Firstly, in the label variable, at the end, before the close bracket, type, comma, f,g equals, apostrophe, red, apostrophe. This will change the text color to red. Then type, comma, b, g equals, apostrophe, black, apostrophe. This will make the background of the label black. Let's also make the main window black. At the top of the code in the window statements, enter a new line and type, window, dot, config, open bracket, background, equals, apostrophe, black, apostrophe. Close bracket. If we now run the code, we can see we have a red label on a black background, in a black window. Now let's have a go at creating an analog-style clock using a similar method. In order to draw on the window, we need to use the canvas method, so, at the top of the script, under the window configuration settings, type my canvas equals tk.canvas, open bracket. Window, comma, width equals 300, comma, height equals 300, close bracket. This will create a canvas with the width and height of 300. Now let's place it in the window. On the next line down, type my canvas dot place open bracket x equals 600, y equals 100 close bracket. Then if we run the code, we can see that a canvas has been created at the x position 600 and y position 100 in the window. Let's change the canvas settings a bit, as we want the background color to be black and we don't want the canvas to have a border. So in the myCanvas variable, at the end before the close bracket, type bg equals apostrophe black apostrophe comma highlight thickness equals 0. This will remove any borders around the canvas and set the background to black. Now that we've got a canvas set up, let's draw the clock face. Under the My Canvas Play section, enter down a new line and type my canvas dot create underscore oval open bracket. This is the Tkinter canvas function used to draw ovals on the screen. Then type 25, 25, 275, 275, Here we are setting the x1 and y1 positions to 25, and the x2 and y2 positions to 275. Then type width equals 10, This sets the line width that the oval will be drawn at. Then type outline equals apostrophe hashtag 93827f apostrophe comma. This is the color of the oval and uses a hex code color. Feel free to change any colors to your preferred colors. Then type fill equals apostrophe hashtag 264653 apostrophe close bracket. This specifies the fill color of the oval. Without it, the oval center would have no color. If we run the code now, we will see an oval has been created on the canvas. Now, let's create a center point for our clock face, which the hands will be attached to. Copy the previous create oval statement and paste it underneath the current line. Edit the x and y values as follows: 145, 145, 155, 155. This will place an oval at the center of our current oval. Also change the fill color to match the outline color by copying and pasting it. Then if we run the code, we can see that the oval has been placed in the center of our clock face. On the next line down in the script, let's create our seconds, minutes and hours hands. Type seconds underscore line equals my canvas dot create underscore line open bracket. Here you can see that Tkinter has a function called create line, which is called in a similar way to the create oval function. Now type 150, 150, 230, 230, Again, this creates a line at the x1, y1, x2, and y2 positions. Now type width equals 5, fill equals apostrophe hashtag symbol e75 f51 apostrophe close bracket. Now if we run the code, we can see that a line has been created from the center point of our clock face, which is at position 150, which goes all the way to our end specified point at 230. In the script, copy the seconds underscore line code and paste it twice underneath on new lines. Change the variable names to minutes underscore line and to hours underscore line. For the width of the minutes underscore line, change the value to 7 and change the fill hex code to hashtag 289DAF. For the hours underscore line, change the width to 10 and change the fill hex code to hashtag D8E1FF. Then run the code. Now we should see that we have all three hands created on our clock face. In order to make these hands move, we will need to use some math functions. The functions will define where the end point of our line should be located. At the top of the script, in the import statements, add a new line and type from math import cos, sin, radians. These are the math functions used to plot positions along our oval. Now, if we go down to our update_time2 function, let's add some more code. Under the label 1 config line of code, let's define how our seconds, minutes and hours are calculated. Where we wrote the variable, current_time, copy out the line of code and paste it under label 1. Then change the variable name to seconds. We only need to display the seconds here, so in the S/T/R/F time settings, remove the reference to hours and minutes. Currently the value will be brought back as a string. We will need to convert it to a number in order to use it in our maths equations, so, in front of the date time, type int, open bracket. Then add a closed bracket to the end of the line of code. On my computer, all the times require a value of 15 to be taken off them to match the current time. You may or may not need this on your computer, but for now, at the end of the line of code, I will type -15 to take off 15 seconds from the returned time. Now, copy this line of code and paste it twice underneath. Change the variable names to minutes and hours. Change the formatting of the minutes to say %, capital letter M. And change the hours to %, capital letter H. Now let's write some math to calculate the end position of our hands. On the next line down, type seconds_y equals 110. This defines the end point of our seconds hand. Now type time symbol, sin, open bracket, radians, open bracket, seconds. So far, this uses the sin and radians maths function and uses the value of seconds which we created earlier. As in a circle there are 360 degrees, but in a minute, there are 60 seconds. We have to divide 360 by 60, which gives us 6, meaning that for each second, the clock hand has to move 6 degrees. So now type times 6 close bracket, plus symbol 150. 150 is the x1 and y1 start position, which is the center of the clock face. Now, copy this line and paste it underneath. Change the name of the variable to seconds_x. In the calculation, change the sin section to cos. Now, copy and paste the 2 seconds lines and paste them underneath. What we need to do now is the same for the minutes hands, so rename the variables to minutes_y and minutes_x. Change the clock end position from 110 to 100 for both variables. Within the brackets that times by 6, change the variable from seconds to minutes for both of the variables. Everything else can remain the same. Copy the minutes variables and paste underneath, rename them to hours_y and hours_x. For the hand length, change it from 100 to 90 for both variables. In the minute 6 seconds, change the variable name to hours. Now for hours, instead of moving by 6 degrees, we need to move by 30 degrees, as there are 12 hours in total on the clock face, so 360 divided by 12 equals 30. Change the values to 30 for both variables. Now that we have defined where we want the endpoints of all our hands to be, we can update them on the canvas for each hand. On the next line down, we can use the coords method. Type my_canvas.coords, open bracket, seconds_line, 150, 150, seconds_x, seconds_y, close bracket. This sets the line position for the seconds hand. Now, copy the line of code and paste it twice underneath. We need to change the variable names within the brackets to minutes_line and minutes_x and minutes_y. Do the same for the hours by naming the variables hours_line, hours_x, and hours_y. Now, every time the after 1000 milliseconds function call is activated, the coordinates for the seconds, minutes and hours line positions will be updated. Run the code to see the result. Here we can see that the analog clock face value matches the time within our digital clock face. This concludes the video on time. There are a number of ways to improve our clocks. We could import a picture rather than create the clock face so that it looks more professional. We could add a stopwatch timer feature, and we could simplify the code slightly. But this video will have given you a basic understanding of how the time and date time functions are used as well as the after function in Tkinter. Stay tuned for more videos.